Welcome to Textbook Engineering Problem, where we explore complex engineering problems and discuss different methods for solving them. In this video, I'll be breaking down a problem and discussing different ways to tackle it. However, keep in mind that there is no one correct path for some of these solutions, and I encourage you to share your own insights and thoughts in the comments. Together, we can learn and improve our problem-solving skills. So, sit back, grab a notebook, and let's dive into today's problem. Today we're working out of Elementary Principles of Chemical Processes 3rd edition, and we're doing problem number 4.8. Eggs are sorted into two sizes, large and extra large, at the Cheerful Chicken Dairy. Unfortunately, business has not been good lately, and since the Cheerful Chicken's 40-year-old egg sorting machine finally gave up the ghost, there have been no funds available to replace it. Instead, old Fred, one of the firm's sharper-eyed employees, has been equipped with a large rubber stamp in his right hand and an extra large stamp in his left, and assigned to stamp each egg with the appropriate label as it goes by on the conveyor belt. Down the line, another employee puts the eggs into either of two hoppers, each egg according to its stamp. The system works reasonably well, all things considered, except that old Fred has a heavy hand and, on the average, breaks 30% of the 120 eggs that pass by him each minute. At the same time, a check of the extra large stream reveals a flow rate of 70 eggs per minute, of which 25 eggs per minute are broken. Part A. Draw and label a flowchart for this process. Okay, so here is part A. I've got an old Fred station, and then I've got a sorting station here. When it comes in, there are 0 eggs broken, and 100% of them are good. Then old Fred stamps them, and 30% are broken, and 70% are good. Then they get sorted, and we know that there are 70 eggs per minute in this extra large stream, and 25 out of 70 are broken, and then that's the number of good eggs. Then we know that the number of large eggs is equal to the number that are going in minus the number that are coming out on the extra large stream, but we don't know the ratio over here. Okay. Part B. Write and solve balances about the egg sorter on total eggs and broken eggs. Okay, how many eggs are broken? We're going to write out our balances here. Okay, so we have in and out of these different processes. If we draw a box around the sorter here, we have a certain amount of eggs going in, a certain amount going out. So this is in minus out, and we're just doing a balance around the broken eggs. That's why we have it multiplied by the fraction of eggs that are broken. We know what these variables are on this side, but we don't know what these variables are. Well, we know what this is because we can solve for that because we've got n2 minus n4, so that's another balance. That's an overall mass balance that we've got right there. Yeah, so our overall balance is here, and then we can solve for what this is as well. So then we get that the fraction of eggs that are broken in stream 3 is 0.22, and the total number of eggs going out stream 3 is 50 eggs per minute. Part C, how many large eggs leave the plant each minute, and what fraction of them are broken? Okay, so part B, we were just doing the balances, so we just had the balance here, and then we wrote our balance here. So part C was the actual solving of these equations in order to calculate what those are. And then part D, this is the cool part. Is old Fred right or left-handed? Now, I thought this was pretty cool because it's a little more critical thinking as opposed to just kind of solving a system of equation or doing a mass balance. So part D, we know that the large stamp is in his right hand and that the extra large stamp is in his left hand. There are 50 eggs that are large per minute, and 22% of them are broken. Then there's 70 eggs per minute, extra large, and 35% of those are broken, about. Now, if we assume that there's only one factor for an egg to break, and that is old Fred's dexterity when he places the stamp on the egg. And then further, if we assume that his dominant hand is the hand that's more dexterous, well, then old Fred is right-handed, because if he's more dexterous with his right hand, he'll break fewer eggs when he does that, when he places the stamp. And that's assuming that the dexterity is the only factor. That's why this part is different, because there could be other factors that go into this, and you guys might get different answers. So it'd be cool to see what your guys' other thoughts are in the comments. You could probably argue that he's left-handed, that maybe he doesn't know his own strength, and his right hand is stronger, and he'll stamp the extra large eggs harder, and so that's why more of those are broken. So you can make an argument either way, and I'd love to see what your guys' thoughts are in the comments. So feel free to drop some good ideas in there. Anyway, that's it for problem number 4.8. Thank you for watching, and I hope you found this video helpful in your problem-solving journey. Remember, there are other routes you can take to arrive at the same correct answer, and I encourage you to leave a comment with any additional insights or questions you may have. Also, if you have any specific engineering problems you would like me to cover, please let me know in the comments. Your feedback is valuable, and I look forward to continuing the conversation with you. Don't forget to like and subscribe for more engineering problem-solving videos. Thanks again, and I'll see you in the next video.